All right. Thanks, everybody, for giving me a chance to talk to you about what we've been doing. Matt, if I would have known I was presenting after you, I'd have hired a better photographer for my picture there. So my name is Justin Kosar. I'm a cyber compliance and security specialist at Associated Electric Cooperative. We are the generation portion of the cooperative. We provide electricity to all of Missouri, the rural areas of Missouri, a little bit of Iowa, a little bit of Oklahoma. We own 8 generating facilities. We've got 2 coal plants and 6 gas plants. We've got 3 combined cycle units and 3 simple cycle units. We manage facilities that are under every different level of SIP compliance. So we've got our EMS systems that are high impact facilities. We've got 5 substations that we manage compliance for that are medium impact facilities, and all of our generating plants are low impact under SIP. With the generating plants, we've got a multitude of different DCS systems. We have Siemens, Westinghouse, ABB, GE, Emerson. We've got a little bit of everything, so that provides some additional challenges in overlaying cybersecurity over all of our systems together. My background at Associated is I started off as a controls engineer. I worked on multiple DCS upgrade projects with several Siemens projects where we upgraded TXP systems to T3000, a big Emerson project at one of our coal plants where we went from partially ABB and partially solid state controls to having an Ovation front end. Over that time, I was working a lot in cybersecurity and kind of preparing for what SIP might bring and how to advance cybersecurity. I liked that a lot, so I moved over into a position that focuses more on cybersecurity. So this is obviously a joke, but it can be kind of difficult sometimes. Most control systems, they've always often been air-gapped. Everyone thinks, okay, if they're disconnected, there's nothing to worry about. We know that's not the case anymore. We've seen the first 2 power outages caused by hackers. We've seen, with Stuxnet in Ukraine, in Iran, we've seen completely air-gapped systems get attacked. So we know that we have to do more. The problem is to figure out what exactly we need to do and how do we focus our efforts. There's lots of challenges also in figuring out if we have a project we want to do. A lot of times it's easy you have plenty of vendors calling and you have technology available. It's easy to see there's lots of things out there that can help, but it's sometimes difficult to justify those projects to leadership when there's no way to measure it. It doesn't make more megawatts. It doesn't immediately save us money. We're going against projects that are going to definitely save money. They're going to reduce maintenance. They're going to improve efficiency. So we have a challenge in presenting a project to improve cybersecurity where we can't show an improvement in a way that our leadership's used to seeing. Once we implement those projects, then it's difficult to measure how well they performed and how much improvement we're actually getting out of it. So we needed to find a way that we could quantify what these different technologies can do to improve cybersecurity. The first thing we did was put together a task force or a committee. We took people from IT departments, compliance, security, from our power production with our controls engineers. We put them all together and we figured out we needed to adopt a framework that we could figure out where we stand right now and how to measure our current level of cybersecurity. We chose the NIST Cybersecurity Framework. If you're not familiar with it, it has 5 functions: identify, protect, detect, respond, recover. Under each of those functions, you've got multiple categories, and then it dives down below that into subcategories where it really gets in the weeds, and you can do the work of analyzing where you're at in every area of cybersecurity. So here's a picture of one part of the identify function of the NIST framework. I picked this one. It has quite a few things that are pretty important parts to get started on improving your maturity. So you've got taking, and it's kind of hard to read, but having inventory of physical devices, inventory of software, mapping data flows throughout your organization, managing vulnerabilities. These are all things that we felt like we were doing something. We had some level of maturity in these areas, but it just wasn't manageable to where we could improve upon it. It was mostly based on, we've got a really good guy at this plant who does some really great work, and he knows what's going on there, but anyone else around the company might not know at all. So we needed something that could centralize all the work that was being done. With this committee, the next thing we did was using the NIST framework and using this criteria. I think this is from a C2, M2. We looked at a lot of different criteria that looked a lot like this. This one had language that mapped well to the NIST categories, and it was pretty descriptive and had different categories. So some things are more process-driven, more people-driven, and some things are technology-driven. So this had language to describe where your organization is in each one of these categories. You could give it a valuable score. We asked people from different groups of our company. We had some IT people, networking, controls engineers, security people, compliance people. We asked them all to score every single subcategory of the NIST framework and score how we're doing in our ICS systems based on one plant's architecture, based on the plant I'm going to talk about here in a little bit. After everyone scored these, we sat down in a room for an entire day and discussed and debated everyone's scores. They were not the same at all. You've got some IT people who have pretty advanced systems that they think that what we're doing in ICS is maybe behind, but they don't understand there's some differences in how things are managed. So we would discuss and debate what we were doing, how each of the categories was managed. And then if people decided to change their scores, they would average everyone's scores together. And we came up with what you can see here is an example of our initial state at this one plant. Based on the previous slide, you could see we're around between a 1 and a 2. So we're doing some good things, but we're not. It's not process driven. It's not the same at every place. So there's a lot to be improved upon in the case for maturity. After we completed the assessment, we had to figure out what were the things we needed to do to get the most benefit to make improvements on the areas we were weakest in. Like I mentioned before, we have a lot of different DCS vendors at all of our plants, so we needed something that would work with any of the different systems we're using. So platform independence was one of the most important things to us. There were plenty of good products offered by all of our DCS vendors, but not only would they only work for that one system, or we have Emerson plant at one coal plant, and we have all these T3000 gas plants. So for us to centrally manage that from our corporate cyber team, it wasn't going to be effective to have multiple systems to do the same thing. Also, sometimes those systems don't offer solutions that you can implement on systems that are adjacent to your controls. You've got like your PI system and your emissions monitoring. You've got things that have tight connections to your controls networks, but they're not exactly part of your control systems. And we wanted to implement these same solutions on those adjacent systems as well. So we wanted something that was completely agnostic when it came to platform. We wanted something that was scalable so that if we added equipment or changed equipment later, we'd be able to add that in ourselves. One of the big features we wanted was asset management. We wanted to always have real-time inventories of anything on our control system or connected to our control system. The single interface is basically something we needed to improve efficiency so we could manage it centrally. Sid mentioned the SIM system that we wanted a SIM to manage logs and manage evidence. We certainly know we're not getting the full benefit of a SIM system yet. We don't have the people or the time to dedicate to it. But to have one place where we're at least aggregating logs and we can go back if an event occurs, we can go back and look at that data. So having a SIM as part of the solution was important to us. File integrity monitoring and change in configuration management. With control systems, I think those are two of the most important things, not just for security, but for operations. And they're things that if you ever see any major changes, it's obviously a big trigger since those are generally static systems. So that was important to have a good change management and file integrity monitoring component to whatever solution we chose. We wanted to be able to do vulnerability scans. Before we did this, we were already monitoring vulnerability alerts from our vendors and from ICS cert, different locations we would get these alerts from. But then to go out and find between 8 plants and you've got different shifts and different people responsible for all these systems to be able to guarantee where might I have this vulnerability that we just heard about, it was really kind of a crapshoot sometimes. We didn't have a dedicated way to say, okay, we can scan this system and this operating system or this software is installed in these places. It was really hard to pinpoint where we would need to go to remediate anything that we found in these vulnerability alerts. So we wanted something that gave us the possibility to scan and find those vulnerabilities. Even if it's not something we're scanning real time, we would at least have, quarterly or we would have baseline scans that were done during outages. Whitelisting is one of the biggest benefits I think we got. With the plant systems, we don't always have patch implementation and antivirus signature updates as quickly as we'd like to. So traditional AV's not as effective as it would be on a normal IT system. And it's not effective at all against zero-day threats. So whitelisting is something that we thought would be a good fit, especially since we don't have a lot of changes in the software that we want to run. They're again, really static systems. We know what needs to run, and we just want to allow only those items to run. The other two items at the bottom, backup management and patch management, that was something that it just takes a lot of time to document and control those processes. So we wanted something to automate it a little bit and to make it easier to manage centrally. We looked at a lot of different products, evaluated based on cost and how many of these features that they could fulfill for us. And we found that Verve Industrial Defender, or Verve Security Center, sorry, not industrial, Verve, the name changes got me screwed up a little bit. Verve Security Center was our best choice. They had people that were familiar with the control systems we use and that they had installed it on similar control systems. So we decided to go with that. It actually aggregates multiple different products like IBM Endpoint Manager, Alien Vault for a SIM, Carbon Black or Bit9 is the whitelisting component. That component offers another benefit that I really like is it does device control. So a lot of the times you hear about vulnerabilities reaching a control system, and what happens is someone goes and plugs in a laptop to make configuration changes, or they plug in a USB stick to move files because there's no easy path via the network to move files you need for updates or any changes, and that device or that laptop is infected, and that's your attack path for getting something bad on your control system. With Carbon Black, we can control which devices can be connected to any of the computers that are managed by Bit9 by serial number. So we have a set of allowed USB devices where we can use to sneakernet information into the control system when we need to. We manage those, scan those, check them out to only specific people, and we feel like that's given us a big improvement on how we can manage transient devices, which right now is not a compliance concern, but pretty soon we all know that's going to be a big issue for plant controls. I think I did two there. So after we implemented Verve, we did a pilot project and we implemented it at one plant at our larger coal plant. And once we got everything up and running, we did another evaluation, and you can see we've got some of these areas here particularly have large improvements. Because we were able to automate a lot of these processes, have more real-time data available, and it's available to more people than just someone at the plant or whoever happens to manage the drawings or manage the asset inventories. So we were able to make pretty big improvements here. And across the entire NIST framework, we made pretty significant improvements. On average, we increased our score by about 1.5 points. As Sid mentioned, there is a capability with this product and with some of the other things we've worked on. You'd think, well, how come it's not a 5? It's basically because we still don't have enough people to really use the full functionality of all these different tools. But with the level that we're able to implement now, this is where we believe we've improved our maturity on the NIST framework. One of the biggest challenges is to getting these projects installed. We always found was competing against other projects that immediately have return on investment. And by using the framework, we've been able to give our leadership the information they need to make better decisions based on where we need to be, even if we're not attacked, even if we didn't get hacked or we didn't get ransomware on any of our systems. We don't have to have something bad happen before we can show them that we need to make these improvements. So.